Hi, this is Mr. Nazarian, and our learning objectives today, we have two of them. Can I classify two-dimensional shapes based on their properties, which is 5th grade standard 5G4, and I can understand how attributes of two-dimensional shapes in a category also belong to all subcategories of those shapes, 5th grade standard 5G3. So, in yesterday's lesson, we talked about quadrilaterals. Today we're going to talk about a different category of polygons, triangles. All right, who doesn't like a good triangle? So the definition of a triangle is a polygon with three sides and three angles. These are the attributes that make a polygon a triangle. And here we have a few different examples of triangles. Okay, now we're going to talk about subcategories of triangles. So this is when we take a broader category like triangles and we break them up to different kinds of triangles. So there's two different ways that we categorize triangles. The first way that we're going to look at is categorizing them by sides. So here's a triangle that I'm sure you'll recognize. It's called an equilateral triangle. And equilateral triangles have three equal length sides. So all three sides of a triangle, if they're all equal, it's an equilateral triangle. Still looking at categorizing by sides. This is an isosceles triangle. An isosceles triangle has two sides that are equal length, and then another side that has a different length side. So this side is different than these two, but these two sides are equal length, so it's an isosceles triangle. Okay. This interesting looking triangle is called a scalene triangle. And scalene triangles are triangles that have all three sides are different lengths. So this is a different length from this, which is a different length from this. None of the sides have matching lengths. And then when we look at this one, we can see that this, although it looks quite different, it's also an isosceles triangle because this side right here is equal to this side. And we'll talk about how this triangle and this triangle are, this triangle are different in just a moment. But as far as categorizing by sides, they're the same type of triangle because they have two equal length sides. And this is the last triangle we're going to look at today. This is also a scalene triangle. So this is the same as this guy over here because each of these sides are different lengths. So again, scalene triangle, when we're talking about sides, means that all three sides are different lengths. Now, and as you can probably tell just by using the eye test, this one and this one look kind of similar even though there's ways that they're different, right? So that's when we're going to start talking about the other way that we categorize triangles, which is by looking at their angles. So if we look at this exact same triangle that was an equilateral triangle because it has three equal length sides, when categorizing by angles, we can see here that it's also called an acute triangle. And an acute triangle has three acute angles. So remember, all triangles have three angles, but acute triangles, all of the angles are acute angles. And acute angles, to review angles, means that it's an angle that's less than 90 degrees, so smaller than a 90-degree angle. So anything that's smaller than, let me use a different, let's just say that this is a 90-degree angle here. Anything that's smaller than that, that goes inside of here, would be an acute angle. So as you can see, this triangle, each of these angles are smaller than 90 degrees. So it's an acute triangle. Okay. Then this green triangle here that we talked about is an isosceles triangle because of its two equal length sides. As we categorize it by angles, it is referred to also as an acute triangle because, again, all three of these angles are acute. So this triangle and this triangle are the same, have the same name as we categorize them by angles, but different names as we categorize them by sides. Okay, and now to this odd-looking triangle that we said, remember, is a scalene triangle because of the three different length sides. As we look at it as out of angles, categorizing by its angles, it's called an obtuse triangle. And it's an obtuse triangle because of this one angle here that's obtuse. And again, so to review angles, an obtuse angle is an angle that's larger than 90 degrees. So we'll just call this right here a 90-degree angle, right? And so an obtuse is even bigger. It's a larger angle than a 90-degree right angle. Okay? So if a triangle has one obtuse triangle, or one obtuse angle, then it's called an obtuse triangle. Okay, now we have this guy that has this nice, neat little corner here that, remember, we call it an isosceles triangle because of the two equal length sides. When we categorize it by angle, it is called a right triangle because it has a one right angle. So because of this angle here, because of this right angle, it's called a right triangle. Okay. And then this last one here, that, remember, we said this one's a scalene triangle, this is an isosceles triangle. It's a scalene triangle, remember, because of when we're talking about the sides, that they're all different lengths. But as we look at their angles, we can see that it is a right triangle as well, just like that last one, because of this one right angle that it has. All right, and I hope that you also picked up that every single one of these subcategories, these types of triangles that we talked about, all have the same attributes of that broader definition of a triangle. All of them have 3 sides and 3 angles. Okay, see you tomorrow.